notebooks, go ahead. First thing is a new, it's not new, but new to us for this year, another formula. You're welcome. It's pretty simple. Volts times amps equals watts. Volts is short for nothing, and voltage, volts. Amps is short for amperes, which is a measure of electrical flow. Volts is you can kind of think of volts like pressure. And then you have watts, which is power, in this case electrical power. So the example I have up there right now, I made it up. I said, hey, a toaster maybe pulls 800 watts max. I don't know. Depends on the toaster, I suppose. So if you have a toaster that uses 800 watts, and we know, because I'm telling you, or you already knew, that like a household plug, like a regular, let me grab this. Oh gosh, don't make a mess. If you have, here's a fan. If you have a regular plug type like this, whether it has the ground or not, this is going to pull 120 volt household power. Does that make sense? Okay. Alternating current, 120 volts. So if you know that, and you know that maybe on the side of the toaster it says 800 watts, then you can do the math. 800 divided by 120 volts gives you 6.6 repeating amps. Here's another one that uses the formula just as it's written there. You don't have to divide. You actually just multiply because this fan right on the side here, it says 120 volts, cool, because it's standard household plug. 0.25 amps. So how many watts does this take to run? It was how many volts? 120 because it's standard US household power. And 0.25, also known as a quarter. 30. There you go. So 120 divided by 4 is the same as 120 times 0.25, right? Yeah. Good. Let's do another one. How about an average microwave? How many watts do you think an average microwave would use? Go ahead. 1,500 watts? That possible. Absolutely. That would be probably more like a restaurant grade, big, powerful unit. In a house, the high end would be like 1,200 or 1,300 watts for one of the bigger over-the-range microwaves. Does that make sense? For a really small to medium size, like countertop microwave, you might be at like 800 watts. So I'd say average size microwave, maybe 1,000 watts. And that's a nice, easy number to work with too, right? 1,000 watts. So plug in 1,000 watts here. Volts is still 120 volts because we're standard household power in the US. I keep saying US because other parts of the world don't have 120 volts as the standard necessarily. So what is 1,000 watts divided by 120 volts? How many amps does a 1,000 watt microwave pull? You need to put it in a calculator. Shh. Everybody a chance to put it in the calculator. Yeah, so if you're looking for amps and you're given watts and volts, you're going to isolate the variable, in this case the amps. So we're going to divide out the volts from both sides, which will leave amps by themselves, which means you're dividing 1,000 watts for the microwave, divided by 120 volts is 8.3. So 8.3 amps. Now, let's say hypothetically, you had a microwave, you put some food in, and you press go, and maybe it's set for like 3 minutes, you're warming it up, or maybe you're set to 5 minutes because you're cooking it, I don't know, whatever. The microwave's going. And then you're like, man, I want some toast with whatever that is. So you put some toast in your toaster. So you've got 6.6 amps, and you have how many amps for the microwave? 8.3, good. What is 8.3 plus 6.6? 14.9. Is that really, really close to 15? Okay, So in some kitchens, you'll have multiple circuits. Does that make sense? So like all of the outlets in your kitchen, let's say you got 10 outlets in your kitchen, you're just decked out with outlets. Chances are not all of them are on the same circuit. Does that make sense? But assuming they were all on the same circuit, if it was a 15 amp circuit, you just maxed it out, didn't you? There's a good chance if you have the toaster going and you start the microwave, it's going to trip your breaker. Does anybody ever have the circuit breaker trip in their house? How many, raise your hand if it's the bathroom because you tried to use a curling iron and a blow dryer at the same time. Yeah. Hey, I know. I've got 4 little girls and a wife. There's lots of hair in my household. Not necessarily on this head, but we've got a lot of hair in the household. So yeah, it's easy to break trip that breaker because bathroom circuits are often 15 amp circuits. Okay. Kitchen circuits can be 15 amp. They might be 20 amp. Often in kitchens you'll find 20 amp circuits. Garages will often have 20 amp circuits because in kitchens and garages you're using maybe a little more heavy duty appliances. Does that make sense? Things that draw more power. Let's see. So looking at this right here, bedrooms, living rooms usually have the light duty circuit. So 15 amp is considered a light duty circuit, not pulling tons of power to them. Kitchens, garages, 20 amp is more of a medium duty circuit. Both of those are at 120 volts. Once you get into 30, 40, 50 amps, now you're considered heavy duty, all right? And in that case, you're at 240 volts. More voltage means you don't need as many amps to get to a certain amount of watts, right? It's a trade-off. If I want 800 watts, let's check this out. If I want 800 watts at 120 volts, I'd need 6.6 amps. But if I wanted that same 800 watts and I'm at 240 volts, now how many amps would I be using? If I double my volts, I can have my amps. Ask me, is 240 times 3.3 repeating about 800 watts? 800 watts? Is that about right? 790. Okay, so we round. So the reason some countries have 240 volt systems is their wiring can be smaller. The reason I have amps underlined in red is because amps, the flow of electricity is what heats up your wiring. It's not the volts, it's the amps that heat up the wiring. But if you have more volts, more pressure flowing through the line, you don't need as many amps. Does that make sense? So you can keep your amps down if you up your voltage to get the same power as a result. Does that make sense? It's actually not that complicated once you kind of get it. So Europe, in most European countries, they have your standard wall outlet will actually be 240 volts. And that way their wiring can be thinner in their wall. Which one?
No. Go down to the right.
We're not here yet. We're not here yet. Stay with me in your note taking. So yeah, heavy duty, 240 volts, and the plugs are going to look different. Has anybody ever seen who has an electric dryer in the house? You see the plug behind there? It's like, looks like a brick almost, right? Yeah. And it's got giant prongs on it, like either 3 or 4 prongs that plug in. How about electric stove? Only one person with an electric stove here. Most of you probably have an electric stove. Okay, if you turn the knob and it doesn't go click, 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 and then fire comes out of it, you probably have an electric stove, all right? That will probably be a 50 amp, and it has one of those goofy looking big giant, you might even, anybody have a dongle come up out of the floor and it plugs in? So it looks like a cord with a cord that plugs into it? Anybody? Some of you wouldn't know unless you pull the stove out to like clean behind it or something. The heat in the wiring, your electrical wiring, it gets hot if you're drawing too many amps, okay? Amps is kind of like flow. The electricity flowing through the wire, the more you have more amps. The circuits are rated for a certain amount of amps to pass through the wiring. If you've got 12 gauge wiring, let me pull up what that looks like. I still have it on. You guys probably seen this like at a hardware store. Right here?
Oh, yeah.
Have you guys ever see the wire?
Yep.
Okay. That's 12-2, so it should have a ground. Yeah, with ground. So you've got it's called Romex, this yellow insulation. Inside of there's a paper insulation. Do you think paper burns?
Yeah.
Do you think this rubberized plastic insulation burns?
Yeah.
If you get it hot enough, it will. And then inside of the plastic, inside of the paper, there's a plain, uninsulated ground wire. It's just copper, right? And then there's a white insulated copper wire. That's your neutral. And there's a black, which is your hot, okay? So all of those, this is 12 gauge, all right? It's the thickness of the wire. You can push 20 amps through this before it fails. Does that make sense? Okay. If you have a 15 amp circuit, you could get 14 gauge. It's a little bit thinner. It's a bigger number, but it means it's thinner wire, okay? They have certain amp ratings. If you exceed the amp ratings, if you try to push more than 20 amps through that, you're going to cause problems. The insulator is going to start to melt, might start to smoke. Where there's smoke, there's might start a fire. Okay, so the circuit breaker in your panel, it trips if it goes above the rating. So if you got a 15 amp circuit and you overload the circuit, as soon as you plug in or turn on an appliance that exceeds the amp rating of that circuit breaker, it flips the switch. It turns off the power to that circuit, because if it doesn't, it would start a fire. Yep. So it's smart, and it's kind of dummy proof. It makes life a lot easier. Before circuit breakers, they had fuses. So instead of a breaker box, you'd have a fuse box in your house. Here's the problem with fuse boxes. People, if they don't know, oh, I'm overloading the circuit, that's why it's blowing out, they just think, oh, it's just a bad fuse. I got to replace the fuse, it's bad. No, it did exactly what it was supposed to do. It saved your house from burning down. But some people didn't understand that. So what they would do is they'd stick a chunk of metal in there to close the connection. Popular one was pennies, I think, for a certain size fuse. You could put a penny in there and it fit just right. And the pennies used to be fully copper, right?
Blow up.
But what won't they do? It won't protect from you overloading the circuit. So anyway, you guys are using breakers and probably, does anybody still have a fuse box at their house? Do you know? Or is it just a breaker, circuit breaker?
Most houses have.
Most have been upgraded, but there might be a few out there. Yeah, well, a lot of the old ones have been upgraded, is what I'm saying. But anyway, you guys understand how a circuit can be overloaded? It's the amps. So I would challenge you this weekend. We got a long weekend, maybe extra long, I don't know. Look at something like, pick your kitchen, okay, and maybe look at your toaster, look at your coffee maker, and just see what amps they pull. And add them up and be like, ooh, I wouldn't be able to run those two things at the same time, or these three things, or whatever it is. How many people, bathrooms, another place where stuff gets tripped a lot because of curling irons or hair dryers? Ladies, a couple of guys with long hair in here. Anybody try to run a hair dryer and somebody else using the curling iron? Does that trip it? Oh yeah, because if it's a 15 amp circuit, and you're running 1,000 watts for your curling iron and 1,500 watts on high for your blow dryer, you're going to push past that 15 amps. Last thing before we move on, there is an 80% rule. When people are designing circuits and engineers are like, we don't want to burn the house down, the 80% rule is kind of a rule of thumb. You should never long term, like if something surges, you guys know what surge watts are for an appliance? when you first start an appliance on, for example, a refrigerator has a compressor, right? When it first kicks on, it draws more power than once it's been running for a few seconds. Does that make sense? To get going, it takes more power than to keep running. So if your circuit is a 15 amp circuit, you probably shouldn't be drawing past like 12 amps constantly, because that wiring is still going to heat up. And what'll happen is if you're too close to 100% capacity, you're going to reduce the lifespan of your wiring. Does that make sense? I mean, imagine if you were going 100% all the time. You're going to burn out, right? As a person. Sometimes you need to back off a little bit. So 80% rule.